Above us, there are billions upon billions of planets, stars, and galaxies, many of which are several times the size of Earth. Because of the enormous scale of the cosmos, we must make some slight adjustments to our understanding of physics.
Inside just one grain of sand, there is an unthinkable amount of atoms, beyond billions and trillions. Even crazier is that atoms still can be broken down into smaller particles. This is the quantum realm. And to understand the universe at such a small scale, we must again adjust our view of the world around us.
When analyzing the world on stellar scales, the most important thing to consider is gravity. In the 1600s, Isaac Newton helped us to measure gravity to great precision. However, we were never able to truly explain it. That is, until Albert Einstein came along. Einstein was finally able to explain gravity by illustrating the universe as a fabric of both space and time. And just like any other fabric, space-time can be distorted. Einstein predicted that massive objects warp the fabric of space-time, causing less massive objects to fall towards it.
When we look at the small things of our universe, things like electrons and quarks, they start acting really weird. Measurements that are defined on normal scales, like position and velocity, become uncertain at quantum levels. Particles are actually too small to measure. In fact, the only way to take accurate measurements in the quantum realm is to assume that the universe is split up into many different sections, or quanta, like a Sicilian pizza. It seems odd to some, but years of quantum mechanical research proves that this leads to correct calculations, meaning that at a fundamental level, the universe consists of many tiny particles. If you look closely at these two theories, you will notice that something is off.
General relativity requires that the universe be smooth and continuous.
Quantum mechanics requires that the universe be disjointed and discontinuous.
These two theories are both experimentally accurate, but have two very different views of the universe, making them incompatible. This has been the dilemma of modern physics for several decades now.
However, there are advancements being made in physics suggesting that these theories are not really incompatible. We are just missing something. That something, it seems like, is string theory.
String theory says something quite simple. String theory states that the fundamental particles, such as electrons and quarks, are actually not point particles like we always thought. Instead, they're actually little strings. This sounds too simple to fix the problem, but it actually says something very profound. Strings, unlike points, can move and vibrate within themselves. These vibrations can explain the different properties for all the quantum particles. Perhaps all these particles are actually made of the same type of string, but they only have different sizes, masses, or energies, because their strings are vibrating at different frequencies.
As interesting as that is, there is something even more profound in this statement. These strings can act as their own quanta. The reason quantum mechanics is quantum is because it assumes the universe itself must be divided. String theory states that the universe does not have to be like this. Instead, the string creates its own limits and leads to the same correct calculations. In string theory, both general relativity and quantum mechanics can work.
String theory has the potential to unify the two great theories of modern physics. If proven correct, string theory will be the theory of everything.
Of course, since string theory is so young, more research must be done before it can be proven true. This could take many years, or even decades, but the results we have now look promising.
String theory is complicated. We barely scratched the surface, but we hope this video helped your understanding. Do you have any questions about physics? Let us know in the comments below.